Picture a photo of sheep grazing in a field. Semantic segmentation would happily paint all of them the same shade. One big blob, simply labeled sheep, with no idea whether it's 5 animals or 50. That's fine if you only care about categories, but useless the moment you need to count or track them. Instant segmentation solves that missing piece. It combines the best of object detection and semantic segmentation, finding each individual object and outlining its exact pixel mask, so it can tell one sheep apart from the next. Let's unpack how it does that. Now, the cleanest way to feel the difference is to put instant segmentation right beside the semantic version we started from. With semantic segmentation, all objects of a class share a single mask. Every sheep pixel is just sheep fused into one region. You get the category and the shape, but the individual animals melt together and the count is completely lost. Instant segmentation hands each object its own mask and its own identity. Sheep 1, sheep 2, sheep 3, each with a distinct outline, even where their bodies touch and overlap. So it answers what, where, exact shape, and crucially which one, all at the same time. That extra which one is the whole reason the task exists. Look, the dominant recipe here has a name worth remembering. Detect, then segment. And mask RCNN is its poster child. Follow one image through it. The pipeline opens with a detector proposing candidate boxes. It scans the image and puts a bounding box around each likely object, roughly locating every countable thing in the scene before any pixel work begins. This is the same detection stage you'd find in a plain object detector, and it does the heavy lifting of saying here is an object and here is another. Each proposed box is then classified. The network decides what sits inside it, sheep or dog or car, and refines the box to hug the object more tightly. Now every candidate carries a label and a cleaner location, which gives the mask step a focused region to work inside rather than the whole messy image. Then comes the segmentation branch. Within each box, a small head predicts a binary mask, coloring in exactly which pixels belong to that one object and which do not. This is the step that turns a rectangle into a precise silhouette. And the output is a separate mask and identity for every instance. Overlapping sheep no longer merge because each got its own box, its own label, and its own pixel mask carved out independently. So let's pin down the 3 things that really make instant segmentation what it is. First, a separate mask for every individual object. This is the whole point. 2 cars parked bumper to bumper get 2 distinct masks and 2 identities, never one merged blob. So counting and tracking each object actually becomes possible. Second, the detect then segment approach epitomized by mask RCNN. Boxes come first, pixel masks come second, layered inside each detection. It's detection and segmentation working together rather than either one alone, and that pairing is what made instant segmentation practical at scale. Third, it masks the countable things, not the amorphous stuff. Cars, people, and animals get instances, while sky and grass are typically ignored altogether. It cares about discrete objects you can point at and count, which is exactly what tasks like cell counting or robotic grasping demand. All right, let's gather the essentials to carry away from this one. Instant segmentation combines detection and segmentation, giving every individual object its own pixel mask and its own identity so separate objects can be told apart. The dominant approach is detect, then segment, epitomized by mask RCNN, which proposes boxes, classifies them, then predicts a mask inside each one. Because it counts and separates objects, It drives robotic grasping, cell counting, per pedestrian tracking, and autonomous driving, and precise photo editing. Want the rest of the Vision Toolkit explained this clearly? We walk through detection and segmentation step by step over at standarity.com. See you in class.